So this math bell work and homework is on using either standard algorithm or partial products to multiply two decimals together. So a decimal by a decimal. In this case, 4.5 times 2.3. So this is an example of how to solve it. These are examples that were already provided for these students on their worksheet, so they should already have that. I'm here to show another example on how to do it. Before I do, I'll explain what is going on here. It was cross-multiplied like with regular numbers, but in the end, you have to determine where to put the decimal point. Okay? Here, we break apart the number, so 4.5, 2.3, and then after you multiply 2 times 4 in here, 0.3 times 4 in here, 2 times 0.5 in here, and 0.3 times 0.5 in here, you add up everything that you get, and you'll get the exact same answer for this strategy and this strategy. I do recommend using this one here because you don't have to worry about whether 0.3 times 0.5 is 0.15 or 1.5. You won't get confused. It would change the whole entire answer if this decimal is wrong but the digits are right. Here, we don't have to worry about that. We just put the decimal point where it belongs at the very end, and I'm going to explain how to do that. So this is our second problem on that worksheet. I'm going to show you guys how to solve this problem, 12.5 times 2.3, or we read it as 12 and 5/10 and 2 and 3/10. So I'm going to line it up using a red pencil instead. Okay, we got it written down. Now I just do cross multiplication. So I do 3 times 5, which is 15. Bring the 1 over there in group. 3 times 2, which is 6, plus the 1, which is 7. And then 3 times 1, which is 3. I go to my next place value on the left, and so I have to put a 0 as a placeholder. Then I do 2 times 5, which is 10, and bring it up the 1 here. I used that 1 before, so I'm not adding it again. But I do 2 times 2, which is 4, plus that 1, and which equals a 5. Then I do 2 times 1, which is 2. Now that I have these these two numbers here, I add it together, straight down. And that gives me 2,875. But we are working with decimals. So I have to think, where do I need to put my decimal? Well, the answer is 28.75. 28 and 75/100. But you ask, well, how did I know that the decimal goes there? Especially since the decimal point here should fall right behind the 7, not in front of the 7. So your answer to that will be explained right now. If I were to put the decimal point, yes, it's fine. If I were to put the decimal point here at 287.5, okay, that will be 287 wholes and 5/10. 287 is a really big whole number. Let's look at 12.5 and 2.3. If I were to round these numbers into whole numbers, because that's easier to look at, 13 and 2, and I were to multiply these together, that would give me 26. That's not even close to a 100, and that's not even close to 200 for sure. So our answer should be around 26, not all the way in the 200s. So that doesn't make any sense. What if I were to put my decimal point after the 5? That gives me an even bigger number, 2,875. So that doesn't make any sense. So that doesn't work out either. And then, what if I put my decimal point here? Again, now that number is too small. Okay? If I were to look at this decimal is only a little bigger than this and smaller than one of my factors to multiply. Our product should not be smaller than any of the numbers we're multiplying, so that doesn't make any sense. So reasonably so, your decimal point should be right in the middle between 8 and 7 and should be 28.75, which if you notice is very similar to 26. Now, you can also count right here, 1, 2, and 2 decimal spaces move over here, 1, 2, and it ends up right there. So that's using standard algorithm. Okay, now I'm going to show you partial products. Now I'm going to set up partial products. So our decimal is 12.5 times 2.3. So when I do partial products, I gotta break apart those numbers to make it workable for my new strategy. So I make a box, and I break apart 12.5 first at the top, and 2.3 out to the side. You can do it either way, it doesn't matter. But if I were to break apart 12.5, it'll be a 10, line, 2, because this 1 represents 10, okay? Because it's 12, not 1 and 2. 10, 2, and then this one is 0.5, which is the same thing as 0.5. Then I have 2.3. Well, the 2 stands for 2, and the 0.3 stands for 0.3, which is the same thing as 0.3. Then I make the line going like this. How do I solve? Well, I multiply these two numbers together, me in the corner. 2 times 10 is 20. 0.3 times 10 is 3. 2 times 2 is 4. 0.3 times 2 is 0.6, or 0.6. 2 times 0.5 is 1.0. And 0.3 times 0.5 is 0.15. What do I do with these random numbers? I add them together. So I add 20 plus 4 plus 3, which gives me 27, plus the 1.0, which is 1 whole. Then I add 0.6 plus 0.15. Okay? Hold on. Alright, so I need to line this up because this might confuse people. 0.6 is the same thing as 0.60. Okay? And that equals 0.75. Okay? And so I add 28 plus 0.75. It's the same thing as having a decimal here. And that'll give us 28.75. Now, for me personally, I feel as if partial products is a bit more difficult when it comes to multiplying decimal by decimal, because students then have to know if 0.3 times 10 is not 3.0, or if it's not 0.3, okay, because it changes the answer. Or 0.3 times 0.5, they might make the mistake of saying 1.5 instead of 0.15, and that will completely show off the answer, change the answer. Unlike this right here, where we don't have to worry about what decimal point it is in when we're multiplying, and at the end all we have to do is determine where the decimal point belongs, unlike this method right here. So I believe that standard algorithm for this is so much better. I'm just going to do the next question, and then that will be it. There are 4 questions on the worksheet, but I'll show 3 of them. And this one I'm not going to do standard, I'm not going to do partial products. I'm just going to do standard algorithm because I already gave 2 examples for partial products, but these are for the people who want to check their answer one more time. And so I line it up. I like to put the bigger decimal on top. It just makes more sense. And visually speaking as well. Alright, so you might notice here that the decimal points do not line up. Do not worry, because in the end we have to determine where the decimal point goes anyway. Right here, we're lining up the numbers, not the decimals. So my 3 and 2 are supposed to be right beneath each other. So now I do 6 times 4, which is 24. 6 times 2, which is 12, and then plus 2 is 14. Okay. 6 times 4 is 24, plus 1, which is 25. And 6 times 1, which is 6, plus the 2, which is 8. Don't worry about the decimal point. Put a 0 for the place value, and then 3 times 4, which is 12. Cross that off. 3 times 2, which is 6, plus 1, which is 7. 4 times 3 is 12. This doesn't add this time. This doesn't add either. 3 times 1, which is 3, plus the 4, and plus the 1, which is 4. I keep saying the answer. Right. Then I add straight down. I'm at a very bad angle right now. This is why my handwriting is just terrible. Anyway, and so we look at this again, and we see basically 14 and 4. Okay, if I were to multiply that together, there's no way I can get a bigger number like 5,206.4 or 5,126.4.0. That doesn't make any sense. It also doesn't make sense to put my decimal here. So what's the most reasonable spot, you say? Well, 51.264. All right, there we go. All right, that is your, oh my gosh, I totally missed a circle. Right, so if you got that, congratulations. So this is the review, just a quick review of multiplying decimals by decimals. Hope you enjoyed. Hopefully it helped. Thank you.